Good morning. This is Teacher Annabelle and welcome to physics class. Well, I would like to ask you some questions. Have you ever think about baking a cake just like this and end up of baking a cake like that? Or or have you ever think about drawing or painting mountains like this and end up with an output like this? Well, it seems to be usual. In life, we have a what we call realistic and ideal, just like our topic for today. Since we are talking about machines, do you think that these machines can work perfectly? Before we begin our lesson, I would like you to prepare the following things with you: your physics book, a pen, a copybook, and a calculator if needed. We are about to continue our lesson about energy. To do that, we need to understand what is efficiency and energy of life. I would like you to open your book on page 158. Our main objectives for today is to define efficiency, demonstrate understanding why machines can be 100% efficient, and describe the role of energy in sustaining life. In a what we call ideal machines, the work input is always equals to the work output. That means the machine is perfect. Just like our lesson last week, we said that the input work and the output work is equal. This example is what we call an ideal machine. If you're going to have an ideal machine, that means that machine works perfectly. But then there's a lot of factors that can affect the performance of a simple machine. In physics, we have a word called efficiency. Efficiency is the percentage of work put into a machine that is converted into useful work output. In mathematical equation, we can describe efficiency as equals to the useful energy output divided by to the total energy input. The efficiency of the machine relies on how it works or the quality of its work. Remember, some machines cannot work perfectly because of some factors, just like friction. Let us take this one as an example. If there is a presence of friction, even we put 100 joules of work on a lever, we can get out 98 joules of work on it. The lever is then 98% efficient and we lose only 2 joules of work input as heat. Another example is using an inclined plane. An inclined plane is a simple machine that can help us in lifting an object using a lesser force than lifting it vertically. However, this inclined plane cannot be used perfectly because of some factors like what we called friction. Now, I would like you to prepare your pen, your copybook, and your calculator and think about this problem. A certain machine is 30% efficient. This means the machine will convert to A. 30% of the energy input to useful work and 70% of the energy input will be wasted. B. 70% of the energy input to useful work and 30% of the energy input will be wasted. Or both of the above. Or letter C, none of the above. Let me see what you got. I'm giving you 1 minute to think about the answer, and the timer starts now. Very good. The answer is letter A. Since it says that machine is 30% efficient, then 30% of the energy input to useful work and 70% of the energy input will be wasted. Excellent, girls. So, why can't the machine be 100% efficient? Excellent. That's because in any machine, some energy is transformed into atomic or molecular kinetic energy, making the machine warmer. That means some of its energy is being released or wasted in the form of heat. Since machines are releasing some waste energy, there are some companies and people who use this wasted energy as another source of energy for a better use. We called it recycling energy. There is a re-employment of energy that otherwise would be wasted. An example of the person is Edison, who used heat from his power plant in New York City to heat buildings. Typical power plants waste about 30% of their energy to heat because they are built away from buildings and other places that uses heat. Well, let us talk about the energy for life. Is energy important or essential for our life? Well, the answer is yes. It says that body or our body is an example of a machine, so it needs energy. Remember that our body is composed of many parts which are working together. Our cells feed on hydrocarbons that release energy when they react with oxygen, like the gasoline which burned in an automobile. It says that there is more energy stored in the food than in the products after metabolism. So remember, when you are eating a certain food, you are using the energy coming from the food. But not all of this energy are being used by your body. Just like a machine, there are some energy which is being wasted or released by our body. Remember cellular respiration and photosynthesis? That's right. These two processes can show you how energy is important for our life. So, what do you think is the role does energy plays in sustaining life? Well, there is more energy stored in the molecules in food than there is in the reaction product after food is metabolized. This energy difference sustains life. Excellent job, girls! This ends our lesson. Thank you for listening. Don't forget to answer your homeworks written in your weekly plan. Bye bye!